Cool. Hi guys. This is Chris from DoraHacks. Welcome everyone to the very first workshop sessions for Avalanche Hackathons on DoraHacks. It's been a very exciting moment for us as the start of the 2024 so that we can start to support Avalanche again. Our first hackathons with Avalanche was between late of the 2022 actually. So and for this time it's actually the second time, and feeling really good to support the Red Army right now. Today, we are very happy to have Richard from Chainlink as the developer advocate to join us to give workshop sessions talking about how to build secure cross-chain applications with Chainlink CCIP. We all know that CCIP is actually a very big topic in the Web3 space right now. Many teams are working on the similar directions, and Chainlink is definitely one of the top teams which have researched and built the relevant solutions for many years. So let's welcome Richard to the stage and start his sessions today.
Yeah, thank you, Chris. I appreciate it. Before I get going too much into CCIP directly, I'm going to take a minute to talk about what Chainlink is as well, just in case you don't have that background. So yeah, I guess I'll go ahead and get started. So I think you're here at this workshop. We can all agree with this comment. Web3 is amazing, right? Like, hopefully we all agree. But it does have a problem. And the problem with Web3 is consensus. So what do I mean by the problem is consensus, right? Like blockchains, they reach consensus, no big deal. What I mean is, let's take a look at a simple question. What's 1 + 1? Not a trick question. Like in your mind, think of the answer. Hopefully we'll all reach consensus across the internet here. 1 + 1, we all agree it's 2, right? It's not a trick question. It's pretty easy. You take 1, add another 1 to it. It's 2. It doesn't matter when I ask you this question. Doesn't matter where you're watching this from. Your answer should be the same. 1 + 1 is 2. That's a deterministic question, and it's really easy to answer those type of things, and blockchains love that type of question. I'm going to ask you a harder question now. I might have to give you a minute so you can figure out the answer. What's the current temperature? Right? Like, well, I'm here in the United States where I'm at. It's about 40 degrees Fahrenheit right now. But it depends, right? Later today, it'll probably be closer to 70. It's going to be a pretty nice day. This is a non-deterministic question, and blockchains have a really hard problem with this type of question. And the real world's filled with this type of data, right? When you have something from the real world, normally the answer is going to be, it depends. And blockchains need to reach consensus. They need to all agree with each other, all the different nodes. And if you take a minute and think about like you and I as 2 nodes in a blockchain, when I answer the current temperature and you answer the current temperature, it's going to be different. And that kind of reminds me of blockchains being like one of my favorite Disney characters, Genie from Aladdin. They have this phenomenal cosmic power. You have transparency. You have a trustless environment, right? You have all of these benefits. They're decentralized, but they live in this itty bitty living space of needing to reach consensus. This is commonly referred to as the Oracle problem, and bringing off-chain data on-chain is ironically kind of solved by oracles. And that's what Chainlink Labs has created, is oracles. So when it comes to oracles, you could build an oracle. Like I could have one sitting, behind me. I could have a little server bringing off-chain data on-chain, just one single node, and saying, the current temperature is. But you've taken the decentralized nature of the blockchain and you've effectively centralized it in one node. So you have a single point of failure. You've reintroduced trust into the equation, all of these problems that blockchains kind of give us a solution to. So Chainlink approached that by creating a decentralized Oracle network, or a DON, D-O-N. And when it comes to that DON, it basically replicates how a blockchain works in that there's a bunch of different independent nodes, and they end up reaching consensus through a consensus mechanism. The simplest way to think about this consensus mechanism is if we take that temperature question, if I'm asking all of you around the world what the temperature is where you are, that doesn't make as much sense as asking like, what's the temperature in my house right now, right? Different rooms in my house could be different temperatures. Still a it depends question, even in the same room, right? If I went to the ceiling and I went to the floor, it's probably slightly different temperatures depending on how specific I want to be. But if I got all the temperatures in my house from all these different locations, and I said something like, what's the median temperature in my house? I've now taken a non-deterministic question, what's the temperature, and turned it into a deterministic one, right? Where I say, what's the median temperature? Given this set of data, what's the median value? And that's the easiest kind of mental model to think about how the Dawn works. Each of the nodes reports back their answer to the question that's being asked. And then the consensus mechanism takes that and creates a deterministic question out of it. Speaking of questions, if you have questions as I'm going through this, feel free to drop them in the chat. I'll do my best to keep an eye on it and answer any questions as we go along. But I'm going to go kind of fast. So feel free to drop them in there and I can go back and we can answer any questions that you have. So Chainlink is a distributed Oracle network. What does that actually give you as the end user? Well, there's a few things. Today, we're going to be focusing on CCIP, which is the Cross-Chain Interoperability Protocol. But I just want to touch real quick on some of the other things that Chainlink offers as well. So data feeds is one. Again, that's going to be bringing that off-chain data on-chain. The most common use case there is asset pair data. What I mean by that is something like USD in terms, or USD pricing for something like ETH or AVAX, right? You need a decentralized answer to what is the current USD value of AVAX. We have VRF, which is Chainlink Verifiable Random Function. And what this provides is a secure method of generating randomness on the blockchain. If you're not familiar with random number generation on a blockchain, it can be kind of tricky because of the deterministic nature of a blockchain. You can kind of know beforehand, before you actually commit a block to the blockchain, what the value of a random function is, and that can be used by bad actors to kind of game the system. VRF lets you get around that by providing a provably random number, and that is used in the same block that you're actually putting it on the blockchain. We have Chainlink Automation, which is a way to use event or time-based triggers to execute functions. This is really important because despite the fact that smart contracts are insanely powerful, they're also pretty lazy in that they won't do anything unless you specifically tell them to go do something. So Chainlink Automation will allow you to do that. You can do triggers based on events from other contracts. You can look at logs and trigger off of that, or you can do time-based triggers as well. We have Chainlink Functions, which allows you to use JavaScript within your smart contracts. You can actually reach out to the Dawn, use some JavaScript that will run in a sandbox on each of the different Dawn nodes, get back information, whether that's a complex computation, can save you gas. You can make an API call or something like that as well. So essentially, Functions opens up the entire internet to your smart contracts. I think that's really powerful, but we're going to be talking about CCIP today and taking a look at a couple of examples of how to use CCIP. So I've got this diagram here. I think probably it's a little more interesting though if we take a look at the documentation. If you head to docs.chain.link, you can look at the CCIP documentation. And this is that same diagram, but it's a little more interesting because it's got stuff moving around. Just to walk through how CCIP works. We basically have two blockchains here, these two rectangles on the screen. So we have our source blockchain and our destination blockchain. Today in the examples that we're going to be walking through, we're going to walk through how to send tokens from one blockchain to another, and also how to send data across. You can send them separately, send tokens or send data, or you can send them together, tokens and data. And I'll show you where those examples are in our documentation. We'll walk through those examples as well. I'll try to go at a pace that if you wanted to follow along, you should be able to. I'll be doing everything straight out of the documentation. I will be making a couple tweaks here and there because our documentation uses some different chains than we'll be using today, but we'll get through that. So how does CCIP work? We'll start over here on the left-hand side. So the end user has a contract that's a sending contract. You can send data and or tokens. They will go to the router. So we'll be deploying this sender contract today, 2 different times. We'll be sending information to the router contract. That router contract then goes to the on-ramp, which will send information to the DONs. Those DONs will do a few things. They'll wait for the source to finalize, stuff like that. The risk management network, I like to think of it high level, is just a black box that keeps everything secure. Our documentation can break down everything as far as how that works if you're interested in learning more about that. But basically, the risk management network takes a look at the transactions, makes sure everything is good. Once it's good, it sends information to the on-ramp so we can take care of the tokens if we're sending them. The tokens that we'll be using today are burn and mint tokens. What that means is on the source chain, when we send them across, they will be burned. They'll be destroyed. Those tokens are gone. And on the destination chain, they will be minted. New tokens will be created. We also could use lock and unlock or lock and mint as well, depending on how the tokens were set up. So lock and unlock means that we have a pool of tokens here. We put our tokens into that pool. They're not coming back to us. They're kind of locked up. On the destination chain, they would be unlocked and then given to us through the router. Excuse me. So we get our tokens or our information, right? It goes to the on-ramp, goes through the DONs. That's a distributed Oracle network. Comes to the off-ramp. That off-ramp talks to the router contract on the destination chain. If we have tokens or data that is coming across, then that will go to our receiver contract. We'll deploy 1 receiver contract today, and that will end up giving information to our end user or that receiver contract. The reason we're only going to deploy 1 receiver contract is because the first example we're going to do, our sender contract will send tokens directly to our EOA. That's an externally owned account or our wallet on the destination chain. And then the second example that we'll do, we'll be sending data across. So we'll have a sender contract and a receiver contract that will receive that data. So before we get started, we may need to get some tokens, all these tokens I keep talking about. Where do we go for that? If you head to faucets.chain.link, you can grab some test tokens. You can grab link tokens, and we will be using link tokens to pay for our transactions today, as well as AVAX if you need it. You could also switch your network here to Sepolia. So we'll be using Fuji Avalanche or Avalanche Fuji, as well as Ethereum Sepolia for our 2 networks today. You can grab any tokens that you need here. The other token that we're going to need is the burn and mint token. So in the documentation under CCIP, under the guides, there's an acquire testnet tokens area here. You could go straight to the contract using the block explorer and mint them there, or you can just connect your wallet and you can mint a token directly to your wallet. And that's what we'll be using today, is one of these CCIP B&M tokens. And again, if you have any questions as we're going through this, feel free to drop them in the chat. So far, it seems like everything is good though, because I haven't seen any questions. So I'm going to keep going. Let's go into the next bit of documentation. How do you get here? Let's just walk through how to get to the documentation. If you go to chain.link, you can go to our docs. If you want to go straight to docs.chain.link, it's probably a little faster. We have each of our products here if you want documentation for them. One thing to kind of point out, when you hover it over it, it'll let you know what chains are supported. And you can see, depending on the product, different chains are supported. So here we'll be using Avalanche to Sepolia, so Fuji to Sepolia. We'll go to our documentation here. We'll go to our guides, and we'll take a look at transfer tokens. Now, before you get started, it does mention here that you need some testnet link as well as some ETH or AVAX in our case. We need to make sure that we're using the correct networks, the supported networks page. we need to acquire some CCIP test tokens as well. So that's going to be those B&M tokens. And then we need to fund our contract at some point during this tutorial. We'll walk through that. For this tutorial, we have here some sample code, and this sample code is quite robust. It will set us up to transfer tokens either with link or with native tokens as well. I keep saying this term link. What the heck is that? It's not the main character from the Zelda franchise in this case. We're talking about the link token, which is basically the native token of the Chainlink Oracle network of that Dawn. It enables us to reimburse the oracles for doing work for us. So we'll take a look at this contract a little bit more in depth once things are going for the CCIP transfer. But like I said, this is a pretty robust contract. It allows you to do a pay with link version as well as a pay with native tokens. So we'll click open in Remix. If you haven't used Remix before, it's just an online IDE that will allow you to deploy and interact with the blockchain. It's pretty awesome. So we've got our contract here. I'm going to go ahead and go through deploying it first, and then we'll look at what it actually does while we're waiting for that CCIP transaction to complete. CCIP does take a minute. There's all those steps where, we have that Dawn in the middle, we have the risk management network, all these different steps that need to take place. One thing to realize is depending on what blockchain you're using for your source chain and your destination chain, it can take different amounts of time. We wait for finality to happen. So what is finality? Basically, it's that point where like a transaction can't be reverted or has a very, very low likelihood of being reverted. And that means that the transaction is done, like it's not gonna, go back. So sometimes it does take time. One nice thing about Avalanche as a blockchain is its finality mechanism is ridiculously fast. So that makes CCIP run a lot faster when you're starting on an Avalanche blockchain and going to another one. So we've opened up this example. Let's go to our deploy tab here and we'll open up our injected provider. Probably, in my opinion, the most confusing and hardest parts of using CCIP involves your wallet and making sure you're on the right network. Can't tell you how many times, like, I think everything's set up and good to go, and then something doesn't work. And it's normally because I'm on the wrong network and I'm trying to interact with like the contract deployed on a different network or something like that. So we've got ourselves on Fuji here. We need to deploy this. We need our router address and our link address. So if we take a look at the documentation here, we've got our massive contract. So it walks us through the steps. This documentation is set up for Sepolia and Polygon's Mumbai network. So we're going to make a couple changes to the steps that are described here, but we can walk through that and I'll show you how to find the information that we need to do things differently. So we've got this set up. Anytime that it says Sepolia, we're going to mentally substitute out Fuji. And anytime it says Polygon Mumbai, we're going to substitute Sepolia. So a little confusing, but we'll get there. So we've got Remix, we've gone to the deploy and run. We need to fill in our blockchain's router and link token contract addresses. So we've got our supported networks page here. So we are on Fuji. So our router address is here. We'll just give it a copy. Come back, give it a paste. And our link token address. Pop those two values in, click transact, and we will deploy this. Confirm, just making sure I was on Fuji. Okay, so we've got our token transfer contract deployed. Once that's done, we need to fund our contract with B&M tokens. We also need to fund them with link. So we'll get our contract address here. We'll go to our wallet. We'll send our contract a little bit of link. And we'll also send our contract some of those B&M tokens. give that a confirm while we're waiting for that. We'll look at, so we're going to transfer tokens and pay in link. So we've already transferred some link to our contract, and then we need to open up MetaMask and fill in the arguments for transfer tokens, pay in link. I did skip one step though, and that was to allow list our destination chain. So there's a little bit of security in here. In order to send things to another chain, we need to give it the chain selector of our destination chain and give it whether or not it's allowed. So our destination chain in this case is Sepolia. So we'll copy the chain selector, paste that in there, and we'll say true. Confirm this transaction. While we're waiting for that transaction to confirm, well, it's so fast. I'm going to pop on over to Sepolia really quick, just to show you what we're going to be doing. So we're going to be sending those B&M tokens from Fuji to Sepolia. If we take a look right now, I have 2.002 B&M tokens. So I'm going to send 0.001 across. So that'll give me 0.003 when everything is said and done. So on Sepolia, I have 0.002. I'll head back to Fuji. And our transaction's good to go. We can double check and see if that chain is allow listed, and it is. So we can transfer tokens, pay in link. So our destination chain, that's the same one that we just allow listed up here. The receiver address, that's going to be my wallet address. So I'll paste that in there. The token is going to be that B&M token. So we go here, we'll take a look at the Fuji to Sepolia lane. We'll grab the token address, paste it in there, and then the amount will transfer 0.001 across, and we'll click transact and confirm. Once we have this confirmation, I just pop in here and grab the transaction hash. Well, the reason I do that is because now I can go to the CCIP Explorer. I can pop in the hash right here, and we can actually take a look at this transaction. So you can see Fuji's already finalized, like on the source side, which is cool. Like finality has been reached, and now we're waiting for all of these steps to happen, right? So this, we're kind of here. We're waiting for all of this part to happen before it gets over here. And like I said, this does take a second. While we're waiting for this to go through, let's take a look at the contract and see what we actually deployed and what we're actually doing here. So walking through this contract, just really quick, high level, we're importing the information from the CCIP contracts up at the top. We've got some errors that we set up. We've got our event that we emit for when the tokens are transferred. We've got our mapping for our allow listed chains. We've got a few other things that we set up in our constructor. When we deployed this, remember, we gave it the router address and the link token address. We've got a modifier for only allow listed chains, and we've got our function to allow list our destination chain. We use that, right? So we said we could send things to Sepolia. And then we have our function transfer tokens, pay in link. So this is the one that we actually used. You can see here we pass in those different things like the destination chain, the receiver address, the token address that we're sending, and how many of those tokens we're sending. What this does is it calls build CCIP message, and we're passing in basically everything that we passed in when we called this function: the receiver, the token, the amount, the link token address, because we're paying in link tokens. We calculate the fees from the router. So how much link is it going to actually take to do this CCIP call? We check to make sure that we have enough link in our contract to pay for that. If it does, then we go ahead and send that link on, and we create our message ID from calling CCIP send. So that's where we actually send that message to the router contract, and we emit, hey, this token transfer happened. Cool. So let's see where our thing is. So it's been blessed. What does that mean? That means that the risk management network has said, yes, everything is good. So we're getting close to actually being done with this transaction. While we wait for this to be successful, I'll go ahead and switch over my network to Sepolia again. And we can see here we've got that success message. So our transaction has gone from Fuji all the way through to Sepolia. And if you see now what was 2.002 is now 2.003. So we did it. We transferred tokens from Fuji to Sepolia. I think that was pretty easy. Like I said, I think the hardest part, and for me at least, and I don't know, maybe I'm just, a little careless when it comes to keeping track of my networks, but that was probably the hardest part, is keeping track of which network it is. And that's going to ramp up for this next example where we send data from one chain to another. So let's take a look at that example. In our guides here, we were looking at transfer tokens. We'll go to send arbitrary data. And again, it talks you through before you begin. There we go. Sorry, it looked like my camera froze. It talks you through before you begin what you need. You need that testnet link. You need the currency of whatever networks you're working on, and like that. So for this one, we are going to deploy this contract twice. We're going to deploy once on Fuji and once on Sepolia. This contract, again, is quite robust. It's a very big contract, but it lets us do both the sending and the receiving, which is pretty dang cool. So we'll go ahead and open this in Remix. Just so I don't confuse myself, I'm going to close this other Remix window. And again, I haven't seen any questions come through yet, but if you do have questions, feel free to drop them in the chat and I will be more than happy to answer them. Okay, so we've got this open in Remix. We'll do the same thing. Let's walk through deploying it, and then we'll walk through what we're actually doing in the contract while we wait for that message to come across. So again, remember in your mind, for our example, super confusing, but Sepolia means Fuji and Mumbai means Sepolia. So deploy your contract under Ethereum Sepolia and enable sending messages to Mumbai, which means deploy on Fuji and enable sending to Sepolia. So we'll go ahead and go to deploy and run, and we'll fill out all of that stuff here. So we've got to do our inject provider. See, I'm on Sepolia. Almost got the wrong network there. Rookie mistake. So make sure we're on Fuji to start with. And for deploy, we need our router and link address. We'll get those from our supported networks page here. So Fuji testnet router. And we'll come back in here for our link address. Go ahead and deploy this. Head back to the docs. So we've got that. We've got our router address, our link. Click transact. Enable it to send messages to not Mumbai, but Sepolia. So we'll go back to our supported networks, pop up here to our chain selector, grab Sepolia's chain selector, go back to Remix, check out our deployed contract here, allow list a destination chain. This is where we're sending our message to. Click transact, click confirm. So we allow listed our destination chain. We'll deploy our receiver contract on Sepolia and enable receiving messages from our sender contract. So we've told our sender contract, hey, you can send messages to Sepolia. And now we're going to deploy a contract on Sepolia and say, hey, you can receive messages from Fuji. And we're actually going to say, you can receive messages from this specific contract on Fuji. So head back to Remix. This is all good. And just to double check, allow listed destination chains, called that's true. Okay, cool. So our sender contract is good to go. Things are going to get even more confusing here. Not only are we dealing with two different networks, but we're going to deploy the contract twice here in Remix. Whew, it's intense. So our router address needs to be for Sepolia. And our link address needs to be for Sepolia. Transact, confirm. BF and 77. Let me just double check those are right. BFN77. Cool. So we've got that done. We need to allow list a source chain. So we need Fuji's chain selector. Grab that. So we have our first contract. This is our sender contract. And then we have our second contract down here. This is our receiver contract. We need to make sure on Sepolia when we're messing with this second one. So we're going to allow list a source chain. Paste that in there and we'll say true. And we are on Sepolia. And then once that's done, we need to allow list our sender contract. So we'll come back to Remix. We'll go up to our sender contract here. We'll copy its address. Come back and we'll say allow list this sender contract. Say true. We'll wait for this. It is done. Okay, cool. Transact. So we've deployed our sender contract, said that it can send to Sepolia. On Sepolia, we've deployed our receiver contract, said we can receive from Fuji, and we can receive from specifically the contract we deployed. So at this point, we're going to do sending data and paying in link. So we need to give our contract some link. Which contract do we need to give link to? We need to give it to this contract, our sender contract. So we need to change from Sepolia back to Fuji, first of all. And then we need to send this contract some link. And we'll confirm. Once that's done, we need to say, hey, this destination chain, this receiver address, this message. So we need our destination chain to be Sepolia. So send message, pay in link, destination chain 1601. Yep. Receiver address will be the address of our contract on Sepolia. And then the string, we just say hello world and transact. And we'll click confirm. While we wait for that to go through, let's go pop on over to Sepolia. We'll grab this transaction hash. Check out the Explorer. Look at our transaction really quick on the Explorer. Okay, so we're waiting again. While we wait, we have switched to Sepolia. So we'll go down to our contract on Sepolia, say, hey, get that last received message. You can see it's nothing so far. So on Sepolia, we don't have a message yet. Common things like if you get errors in this thing, make sure you're on the right chain. I can't tell you how many times I've clicked this and gotten a weird error message right here. I'm like, what the heck is going on? And it's because I'm trying to call whatever contract is deployed at this address on Fuji, and it's not this contract. While we wait for that to get done, we'll do the same thing. We'll walk through this contract as well. We've got similar imports here where we're importing in our CCIP contracts from Chainlink. We've got our contract set up here. We've got some errors. We've got our event for our message sent and received. We've got mappings for our allow lists of senders, destination, source chains. Our constructor looks pretty similar to the constructor that we used to deploy the other contract. We've got our allow list modifiers. We've got our functions to allow list different things. And we've got our send message, pay, and link. One thing I didn't mention in the other one, there's another function in both of these where pay and native. It's very similar to this pay and link function. Very similar to the other one as well. We've set up our values. We pass in our values, I should say, of our destination chain selector, the receiver. In this case, we're also sending the text. So we're not dealing with tokens, we're dealing with data. And then we build our CCIP message. It looks very similar to what we had in the other example we looked at. We've got our router, we calculate our fees, we check to make sure that we have enough link to pay for those fees. We get our message ID back from that CCIP send, and we emit our message sent. very similar, right? The other thing, so we've got our send message pay in native. And then we have our CCIP receive function. So this is different. This isn't in that other contract. This is actually where that information comes in. So this function, the CCIP receive, that's where we'll deal with any data that comes in. So we get in our data. In this case, we're just saving our message ID and our text to some values that are in this contract. If you wanted to do something with the data that comes across, this is where you would do it. But in this case, we're just saving that data and we're emitting, hey, we got a message received. So let's take a look at our Explorer and see where we're at. We're blessed. So we're almost there. Should be there shortly. Again, I'll give you all a chance. Any questions, comments, thoughts? While we wait for this, we can take a look at some of the other documentation really quick. Whoops, where do we go here? So we looked at transferring tokens individually. We looked at sending data as well. There is an example where you can transfer tokens and data together. If you wanted to pay for something to happen at the same time that you are sending the what you want it to happen, this is a great way to do this, right? So if you needed to pay for a function to be run on the destination chain, something like that. There are a few chains that use USDC, so you can look at that. So you can actually send USDC between chains. Only a few chains are supported right now, but we're always adding more as well. Take a look here and see where we are. Hey, we got success. Okay. So we come here and we say get last received message details now. See, we have our ID and our text of hello world. So I was on Fuji Avalanche. I interacted with a contract and I said, hey, send some data across to Sepolia. And it worked. And we have data received on the Sepolia side. I think that's pretty massive. I mean, between this and like functions, Web3 has changed a lot in my mind. And that's pretty awesome. The ability to send not just tokens across, but data across between chains means that you can build apps that are basically chain agnostic, right? They can live on one chain and another chain. They can talk to each other between those chains. That's pretty awesome. So yeah, I guess I'll hang out for just a couple more seconds. If you have any questions, drop them in the chat. Otherwise, that's CCIP, high level how to use it. Look forward to seeing what y'all build with it, because I think this technology is pretty cool and I think the possibilities are pretty amazing. So yeah, I'll hang out for just a couple more seconds. It doesn't look like there's many questions though, so I'm not gonna hang out for too long. Hey, Chris.
Hey, Richard. Thank you very much for this very detailed workshop. I actually do have like one questions regarding the CCIP, but not like very technical one. Just trying to understand a little bit more about the CCIP from Chainlink and the CCTP of Circle. I also saw that like Circle have launched a partnership with Chainlink together like couple days ago on Twitter. I'm not sure like what is the play there, but for Circle it's very quite obvious that like they just want to transfer the native USDC coin between different networks to reduce the slippage and fraction for users. So like for Chainlink CCIP, is there like any major difference that like or notable difference between between the solution compared with CCTP, I guess?
Yeah, so I think you answered your own question. Because you mentioned that CCTP is about transferring the Circle token around.
Yeah.
Right. And so that's what it's for. CCIP can also like with the USDC transfer, like you can transfer USDC tokens, but you can do a lot more stuff too, right? So it's not just about that one thing. And I think that's where they're just kind of different use cases. Like one use case is a lot broader than the other. So yeah, that's how I'd answer that question. Like CCIP, you can do a ton more.
Got it.
For sure.
Yeah, that makes sense. Cool.
Yeah.
I think that's my questions.
Okay.
And if there's no more questions from audience, I guess we can wrap up here. But really appreciate your time today for this amazing workshop. It's definitely make a lot of sense and should be very helpful for any of the developers who want to utilize the CCIP functions during the hackathon. So definitely looking forward to all of the upcoming submissions of the hackathon that can leverage the CCIP. If for all of our audience, if you have any questions during the sessions, please feel free to reach out to us later if you didn't got a chance to ask during the live stream sessions. There will be a couple more workshops following up. And if you don't want to miss out those sessions, definitely keep your eyes on DoraHacks Twitter and Avalanche Twitter. We will announce all of the newest news there. And yeah, that'll be all for today. Thanks again, Richard, for your time. And yeah.
Yeah, thank you. And I will say, if anyone has questions too, we have a Discord for Chainlink that is a great place. Also, down over here somewhere is my Twitter X handle. Like, you can feel free to reach out to me there if you have questions as well.
Amazing. Yeah, I didn't notice that there's a Twitter handle, but yeah, thank you very much, Richard.
Sure thing.
Thank you. Have a good one.
You too.